Welcome to online learning program of MSBT Learning at Your Doorstep. I am Sangeeta Boyer, lecturer at ES Polytechnic, Chembur, Mumbai. Today we are going to discuss very first topic, that is addressing mode from Unit 2, Instruction Set and Programming. In first unit, you have already learned about the details of 8051 microcontroller. You have learned block diagram, pin diagram, architecture, memory organization in 8051 microcontroller. So, today's learning outcome is to identify addressing modes of the given instructions. Under this, we will see how operands can be accessed in 8051 microcontroller and identifying different addressing mode of given instructions. This is the concept map, shows 5 different types of addressing modes: immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, and indexed addressing mode. Addressing mode. Addressing mode refers to the method used to identify the location or value of an operand. It defines the way in which the operands are accessed by the instruction. Any instruction in 8051 microcontroller has two parts, an opcode and an operand. The opcode tells the microcontroller what to do. Operand means the data we are operating upon. It can be direct address of memory, it can be register name, or it can be any numerical data. Here, in this example, A is the destination operand and 6A is the source operand. After the execution of this instruction, data 6A is moved to accumulator A. There are 5 different ways to execute this instruction, and hence we say we have got 5 addressing modes of 8051, that is immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, and indexed addressing mode. Immediate addressing mode. In this addressing mode, the data is directly specified in the instruction itself. The source is the immediate data and the destination of this instruction could be any register. Hash symbol specifies that the operand is an immediate data on which operation is to be performed, and the result will be stored in the destination register. For example, move A, #23H. Here, A is one of the special function register in 8051 acting as a destination register, and #23 is an immediate data. After the execution of this instruction, 8-bit data 23H will move to accumulator. Next instruction, move R3, #0FAH. In this case, register R3 acting as a destination register, which is one of the register in selected register bank, and FA is an intermediate data. Here, 0 is added at the beginning because when the data is starting with A to F, the data should be preceded by 0. After the execution of this instruction, data FAH will move to register R3. Direct addressing mode. In this addressing mode, the direct address of the operand is specified in the instruction itself. Internal RAM addresses starting from location 00 to 7FH and SFR addresses starting from ATH to FFH are only allowed in the direct addressing mode. For example, move A, 23H. Here, accumulator is the destination register and RAM address 23H is the source operand. After the execution of this instruction, the content of memory location 23H will move to accumulator. Next example is move R1, 24H. Here, in this case, destination is register R1 and source is RAM location 24H. After the execution of this instruction, content of 24H memory location will copy to register R1. Next instruction is move 26H, 33H. Here, both source and destination are RAM location. After the execution of this instruction, content of memory location 33H will copy to memory location 26H. Next is register addressing mode. In this register addressing mode, the data is specified in the register for various operations as per the given instruction. Only the accumulator A and R0 to R7 registers of each memory bank are allowed in this mode to transfer the data. The data transfer can take place between Rn registers and accumulator only and cannot be done between Rn register. For example, move A, R3. Here, destination is accumulator and source is register R3. After the execution of this register, the content of register R3 are copied to accumulator. Second example, move R3, A. Here, destination is register R3 and source is accumulator. After the execution of this instruction, the contents of accumulator are copied to register R3. Now, before we proceed further, please attempt MCQs from set 1, which is given you as assessment sheet. Proceeding further, we have register indirect addressing mode. In this mode, the source or destination address is given in the register. By using register indirect addressing mode, the internal or external addresses can be accessed. It may point the lower 128 bytes of the internal RAM addresses, that is from 00H to 7FH, or the lower 256 bytes of the external data memory. The register R0 or R1 is used to hold the address of internal RAM from 00H to 7FH. The register R0 or R1 or DPTR is used to hold the address of lower 256 bytes of external data memory. Example of register indirect addressing mode. Move 60H, @R0. Here, @sign is used in the instruction and placed before R0 to make this register as pointer. After the execution of this instruction, the content of memory location held by register R0, that is 25H, is copied to memory location 26H. Second example, move @R1, 30H. In this case, after the execution of this instruction, content of 30H memory location is copied to the memory location held by register R1, that is 41H. Next example, move X A, @DPTR. Here, X is used in mnemonic to indicate external memory. After the execution of this instruction, the content of the external RAM location held by DPTR are copied to the accumulator. Next example, move X A, @R0. The content of the external RAM location held by register R0 are copied to the accumulator. Indexed addressing mode. This mode allows a byte to be addressed from the program memory, whose address is calculated as the sum of a base register and index register. Base register can be data pointer or program counter, and index register is accumulator. This mode is used to access data from the code memory and is denoted by C in the instruction. Example, move C A, @A plus DPTR. In this instruction, contents of the ROM location pointed by the sum of addresses A and DPTR are copied to accumulator. In this case, the data pointer holds the base address and the accumulator holds the index or displacement. Move C A, @A plus PC. Contents of ROM location pointed by the sum of addresses A and PC are copied to accumulator A. Now, please take MCQs from set 2, which are given in your assessment sheet. Let us take quickly recap of important points. First is immediate addressing mode. In this mode, the data is directly specified in the instruction itself. Hash symbol is used in the instruction. Second is direct addressing mode. The direct address of the operand is given in the instruction itself in this addressing mode. Third is register addressing mode. The data is specified in the register for various operations in this operating mode. Register indirect addressing mode. In this mode, the source or destination is given in the register. R0 and R1 are used for 8-bit addresses and DPTR register is used for 16-bit addresses. Next is in-text addressing mode. This is used to access data in internal or external ROM, and indirect address is given by using A with program counter or accumulator with data pointer. Thank you.